Hello everyone, it is Mr. Gear and I'm coming to you from inside your computer, and I'm here today to talk about writing linear functions. This is backwards of what we did last time. Instead of taking a function and putting it on a graph, now we're taking some information, perhaps even a graph, and we're making a y equals mx plus b from it. You will find in my Blackboard site notes on writing linear functions, and it basically comes down to this. Can we take some information and make a y equals mx plus b from it? If we can, we're golden. And it's pretty simple. Find the slope, find the y-intercept, and you've got yourself a linear function. Now, finding the slope, you can do either by using the slope formula, or just reading it directly from the graph, or stealing from a parallel or perpendicular line. Finding the y-intercept can be a little bit more challenging. And in fact, there's two different ways really to go about it. The back of my notes talk about plugging in an x and y point and solving for b, or using the point slope form. I kind of like the first method better. Let me jump now to what we're doing. We're writing a linear function, y equals mx plus b, when you're given a point in the slope, or 2 points, or if you have a parallel or perpendicular line and a point, you can steal the slope from there. I want to run through a couple of the problems that we have on our worksheet. Go through the notes, make sure you're clear on those, but I want to run through a couple of these to show you what we're talking about. Write an equation. Write a y equals mx plus b. When you're given the slope and the intercept, it takes about 2 seconds because all the information you need is there. The m and the b, they're right there. Y equals negative 1/7 x minus 2, because both of the pieces of information you need are right there. If you're given a graph, that information is also right here. The y-intercept is where the line crosses the y-axis. So the y-intercept is 3. The slope, I'll take these 2 points and figure out what the slope was. To get from here to here, I went up 1 and over 4. So the slope is 1/4. Y equals 1/4 x plus 3. As long as you can find the slope and find the y-intercept, you're golden. Finding the slope might take a little bit of work. We see here 2 points. The slope formula said we could take negative 4 minus 3, that's the two y values, and put that over 3 minus 12 and see what we get. This would make negative 7 over negative 9. The two negatives would cancel out and tell us that our slope here is 7/9. You can do the same thing with this one. You just have to pick a couple of points to do it from. Here are your y values, here are your x values. Now here's where it gets interesting. I have a slope, but I don't have the intercept. I have some other point on the graph. I can do this one too. The problem is I can't just write y equals mx plus b, because I know the slope, but I don't know the y-intercept. I don't know the b. I do know the slope though, so why not go ahead and write the slope right here where it goes. And here's what else I know. I have a clue. I have an x and a y value that I know work in this function. Let's put those in, and then we'll be able to solve back for b. I'm going to put the 11 over here where y is. My slope of 7/3 is going to be times the x value, which is 3, at least at that moment. And that's all plus the still unknown value of b. I can solve this for b. 7/3 times 3, the 3 and the over 3 are going to cancel each other out. So I'm going to be left with 11 equals 7 plus b. And when I subtract 7 from both sides, I wind up with 4 equals b. Ta-da! Now I know what the b is, and I'm ready to write my equation of this line. It's y equals 7/3 x plus 4. That was pretty easy, wasn't it? Okay, it wasn't that easy, but the process is something that you can get through. Write the function, plug in the slope that you know, plug in the x and the y that you know, solve for b, and then once you know the b, you're ready to write the function. Let's try it again, and a couple of times really. Here's another point on the line and the slope, which means over here at 3 over and 9 up, that's a point on my line, and my line has a slope of 4. It's going to go something like this, but that's not a very good line, so I'm going to get rid of that. And I'm going to say, let's find the function of the line. Let's find its equation. Y equals 4x plus whatever the y-intercept is, b. I know it's 4 because it was given to me right there. I can't plug this in for b, but I can plug it in for x and y. So 9 equals 4 times 3 plus b. You see the x and the y plugged in here now, right? 9 equals 12 plus b. And when I subtract 12 from both sides, I get that b is negative 3. So my equation is y equals 4, the slope I had before, x minus 3. One more time? Sure. Here's a slope. Here's a point on the line. It's going to be over here at negative 4, 3. My line's going to go through that with a slope of approximately 2, but I want better than that, so I'm going to write the actual function, y equals 2x plus my still unknown intercept b. My y is 3 from above. My x is negative 4 from above. And now I'm just going to solve. This is pretty simple algebra at this point. Add 8 to both sides and discover that b is 11. So y equals 2x plus 11 is my function for this particular line. Wow, my intercept's going to be way up here at 11, isn't it? That's what it looked like. Okay, I missed the point. You get my point, though. I'll come back to this in a second. I want to come back here to show that I could also do it with this. I just have to figure out the slope first by taking y2 minus y1 over x2 minus x1. I know my slope. I don't know my intercept, but I do know a point on the line. Any of these will be a point on the line. Plug that x and y back into that original equation, and you're there. Finally, I want to discuss for just a second, if I'm given not a slope, but instead a parallel line, then steal that slope. My slope is going to be the same as that one. If I'm given a perpendicular line, then steal that slope. Only it's not the same, because perpendiculars actually have negative reciprocal slopes. But now that I have my slope and a point on the line, that previous process is all I need. So to go back to your notes and recap, we are using some information that you're given to write a math model, a y equals mx plus b, a linear function to describe what's happening with this particular x going in and y going out data. If you have any 2 points, you can make a line. If you have a point and the slope, you can use that in the process we just showed to come up with the y-intercept to create your y equals mx plus b. If you only have 2 points but don't have the slope, then first find the slope from those 2 points. Then write your y equals mx plus b with the slope and use the process we just figured to find your y-intercept. Just as a side note, you don't have to go through that process. You can use point-slope form to do basically the same thing. If you want to know more about that, check the book section 2.4. Good luck!